Good morning, all of you. Peace be upon you and your family. How to write and name bimetallic complexes. As usual, in the previous videos, we have discussed how to write and name cationic complexes and anionic complexes. Now, bimetallic complexes. For that, first we should know the central metal ions used. Monopositive ions are Ag plus and Au plus monopositive central metal ion. Coordination number of these ions are equal to 2. Dipositive ion example, copper 2 plus, nickel 2 plus, platinum 2 plus, Zn 2 plus, coordination number equal to 4. Tripositive central metal ions are cobalt 3 plus, chromium 3 plus, iron 3 plus, and iron 2 plus, coordination number equal to 6. If nickel and platinum are in 4 plus oxidation state, their coordination number equal to 6. And one more things, you know about the monodentate neutral ligand, monodentate negative ligand, bidentate neutral ligand, and bidentate negative ligand. So using this, now we are going to write a bimetallic complexes. That means complex cation and complex anion. Complex cation and complex anion collectively gives a coordination compound. If you want to write the cationic complex first, the ligands are used are neutral ligand and more number of neutral ligand you have to write. More number of neutral ligand. More number of neutral ligand you have to write. If the coordination sphere is negative, you should select negative ligand. Negative ligand or more number of negative ligand. More number of negative ligand. That gives the coordination sphere negative. This gives the coordination sphere positive. So by remembering this, we are going to write a number of bimetallic complexes and also name the bimetallic complexes. Starting with coordination number 2, monopositive cation. Monopositive cation. Ag plus coordination number 2. To get the first complex positive, here I am using a neutral ligand. Amine NH3, amine NH3. One amine charge 0, 2 into 0 equal to 0. When you add these two, plus 1 plus 0 gives you plus 1. And along with it, now we are going to use a negative complex. Gold Au plus 1, gold plus 1. Coordination number of gold is 2. To get negative charge, here we have to use a negative ligand. For example, Cn, cyanidocapacity, 1 Cn 1 minus, 2 Cn 2 minus. When you add these two, you will get minus 1 on the complexes. That one is here, this one is there. A bimetallic complex is obtained. Now, with the same coordination number 2, now I am writing with bidentate ligand. Ag plus 1 Coordination number 2. This ligand form 2 bonds with the central metal ion. Now I am writing the negative bidentate ligand En ethane 1,2 diamine. It is a bidentate ligand. We know a bidentate ligand form 2 bonds with the central metal ion. There is no 2 here. Here we use it 2. It is a monodentate ligand. One ligand form 1 bond, 2 ligand form 2 bonds. But it is a bidentate ligand. One ligand form 2 bonds. It is a neutral. Therefore 0, +1, 0, +1 come to another complexes with the negative charge. Au gold monopositive coordination number equal to 2. One bidentate OX. OX means oxalato. Oxalato. 1 oxalato 2 minus. 1 plus 2 minus gives 1 minus. That one is here. This one is there. Then come to another complexes, bimetallic complexes. Au central metal ion +1. We are going to write coordination number 2 is now fulfilled by 2 monodentate ligand. To get positive coordination sphere, first one monodentate amine, another one monodentate aqua are used here. Then it is neutralized by another coordination sphere with another central metal ion Ag plus. To get negative charge on this coordination sphere, Cl and Br are used. Cl and Br are used. Cl is -1, Br -1. When you add all these charges, you will get -1 and amine 0, aqua 0. When you add all these charges, you will get +1 on the complex. When you crash, that one is here, this one is there. And come to coordination number 4, copper 2 plus and other ions, central metal ions. Starting with copper 2 plus, central metal ion copper 2 plus. To get positive cationic complex, first more number of negative ligand or all negative ligand. Coordination number 4. Now in the coordination number 4, all the coordination bond is formed by neutral ligand H2O0. Aqua is a neutral ligand. 4 into 0 equal to 0. 2 plus 0 will give 2 plus on the complex. Again nickel Ni 2 plus coordination number 4. To get anionic complexes, the ligand used are I. 1 iodine 1 minus, 4 iodine 4 minus. When you add these two, you will get 2 minus on the complexes. That 2 should be written here, this 2 there, 2 get cancelled. This is the complex. And so here all the ligands are neutral ligand. Now change the ligands here. Same coordination number 4. The central metal ion here is copper 2 plus. Now here all the ligands are neutral ligand. Now the 4 is divided into 3 plus 1. 3 plus 1. More number of neutral ligand. You can use here H2O or amine NH3, 1Cn negative ligand. Amine neutral ligand charge 0, 3 into 0 equal to 0, Cn -1. When you add these two, you will get +1 on the complex. Then another one complex, platinum coordination number 4. Now we are going to use negative and also neutral ligand. More number of negative ligand should be used to get negative complex, anionic complex. So Cn thrice 1NH3, 1 Cn 1 minus, 3 Cn 3 minus, amine 0. When you add all these charges, you will get -1 on the complex. That one is here, this one is there. And again we are going to write more number of the bimetallic complexes. Bimetallic complexes. After writing the complexes, then name, how to name all these bimetallic complexes. Now I am going to write the coordination number 4 with bidentate ligand. Nickel 2 plus coordination number 4. That coordination number 4 is occupied by the neutral bidentate ligand ethane 1,2 diamine. 1 ethylene diamine form 2 bond, therefore 2 ethylene diamine form 4 bond. Ni2 plus En twice along with another coordination number 4 central metal ion platinum 2 plus coordination number 4, but here I am going to use a bidentate negative ligand oxalato, OX oxalato. 1 oxalato form 2 bond, therefore 2 oxalato form 4 bond. Ethylene diamine is a neutral ligand, charge 0, 2 into 0 equal to 0. When you add these two, we will get 2 plus on the first complex. 1 oxalato, 2 minus, 2 oxalato, 4 minus. When we add these two, we will get 2 minus on the complexes. That 2 is here, this 2 is there, 2 get cancelled. Then again, the mixture of bidentate and monodentate ligand, we are going to write mixture of bidentate and monodentate ligand. Taking an example of platinum 2 plus coordination number 4. Coordination number 4 means there are 4 bonds formed between central metal ion and ligand. Among the 4 bonds, 2 bonds are occupied by ethylene diamine or ethane 1,2 diamine, NH3 1 monodentate ligand, and 1 negative ligand also you can use. Coordination number 4 is over. 1 ethylene diamine 2 bond, third bond occupied by amine, fourth bond occupied by Cl minus. Amine is a neutral ligand, charge 0. Ethylene diamine is a neutral ligand, charge 0. Cl negative ligand minus 1. When you add all these, you will get plus 1 on the complex. Then coordination number 4, zinc 2 plus, coordination number 4. To get anionic complex, we have to use more number of negative ligand or more number of coordination number is occupied by negative ligand. 1 oxalato, oxalato is a bidentate negative ligand. 2 bonds are filled by oxalato, then another 1 bond, third bond, fourth bond is occupied by NH3. Oxalato, 1 oxalato, 2 minus, 1 chlorine, 1 minus, amine is 0. When you add all these, you will get minus 1. That 1 should be written here, this one there. Then come to coordination number 6, complexes. Simple complex, cobalt, oxidation state 3 plus. Coordination number 6, NH3, how many times? 6 times. NH3 6 times. Amine. Amine is a neutral ligand, charge equal to 0, 1 amine 0, 6 into 0 equal to 0, charge on the complex is 3 plus. And another Cr, 3 plus. Ligands, negative ligands, we are going to use Cn 1 minus, 6 Cn 6 minus. When you add these two, we will get 3 minus on the complex. That 3 is here, this 3 is there. 3 get cancelled. Then come to mixed ligand. Cobalt, oxidation state 3 plus. More number of negative ligand. 6 is divided into 5 plus 1. More number of negative ligand, H2O 5 times and 1 negative ligand. Neutral ligand, more number negative ligand. Neutral ligand charge equal to 0, 1 aqua 0, 5 into 0 equal to 0, 1 Cn minus 1. When you add all these, you will get 2 plus on the complex. Then another coordination number 6, central metal ion, chromium 3 plus. Now to get anionic complex, we have to use more number of negative ligand along with and one neutral ligand. Cn negative ligand, aqua neutral ligand, 1 Cn 1 minus, 5 Cn 5 minus, aqua 0. When you add all these, you will get 2 minus, that 2 is here, this 2 is there, 2 get cancelled. And come to ion complexes, Fe ion complexes, starting with Fe 3 plus ion, ferric ion, coordination number 6. Ethylene diamine, one ethylene diamine form 2 bonds with the central metal ion, 2 ethylene diamine form 4 bond, and another 2 ligands are negative ligands. One ethylene diamine neutral ligand 0, 2 ethylene diamine 2 into 0 equal to 0, 1 chlorine 1 minus, 2 chlorine 2 minus, 3 plus minus 2 gives plus 1 on the complex. Then cobalt 3 plus going to form anionic complex, coordination number 6, oxalato OX, 1 oxalato form 2 bond, 2 oxalato form 4 bond. Then another 2 bonds are occupied by aqua twice. Oxalato 2 minus, 2 oxalato 4 minus, aqua 0, 2 into 0 equal to 0. When you add these two, you will get minus 1. That one is written here, this one is written there. Come to another ion complexes. Here the charge on the complex going to change. Fe 3 plus ion, Fe 3 plus ion, coordination number 6. That coordination number 6 is now divided into 4 plus 2. 4 coordinate bonds are occupied by amine NH3 4 times, Cn NO2. Come to negative complexes, amine 0, 4 into 0 equal to 0, cyanido minus 1, nitrito minus 1. These two are ambidentate ligand. When you add all these charges, you will get plus 1 on the complexes. Then again minus 1. Fe2 plus, Fe2 plus, Cn 4 times, coordination number 6. Here 4 bonds are occupied by cyanido. Another 2 bonds are occupied by aqua. Cn neutral negative ligand, 1 Cn 1 minus, 4 Cn 4 minus, aqua neutral ligand 0, 2 into 0 equal to 0. When you add these two, you will get minus 2 on the complexes. Here plus 1, there minus 2. So that 2 is written here, this one should be written there. There is no cancellation. Another one ligand we are going to write here. Chromium 3 plus, coordination number 6 is now divided into 4 plus 2. To get cationic complexes, more number of neutral ligand and another 2 coordinate sides are occupied by negative ligand. 1 aqua 0, 4 into 0 equal to 0, 1 chlorine minus 1, 2 chlorine minus 2. When you add all these, you will get plus 1 on the complex. Cobalt CO 3 plus ion, 4 plus 2, 4 plus 2, but here 4 is occupied by negative ligand and 2 is occupied by neutral ligand. 2 is occupied by neutral ligand to get anionic complex. 4 chlorine and 2 aqua, 1 chlorine 1 minus, 4 chlorine 4 minus, 1 aqua 0, 2 into 0 equal to 0. When you add all these, you will get minus 1. That one is here, this one is there. Then 2 more complexes we are going to write with the coordination number 6. Chromium 3 plus, And aqua H2O, how many times? 6 times. A simple complex. Aqua is a neutral ligand, charge equal to 0, 1 aqua 0, 6 into 0 equal to 0. So the charge on complex is 3 plus. Again, we have to write one anionic complexes along with this. Chromium 3 plus, coordination number 6. Coordination number 6 is now divided into 5 plus 1, 5 negative ligand and 1 neutral ligand. Cn, there, NH3. Find out the charge, 1 Cn 1 minus, 5 Cn 5 minus. Amine neutral ligand 0. When you add these two, you will get minus 2 on the complexes. That 2 should be written here, this 3 there. There is no cancellation. And one more, complexes with the bidentate ligand. Cr3 plus, coordination number 6. All the 6 coordination site are occupied by ethylene diamine, neutral bidentate ligand, neutral 0, 3 plus on the complexes, that is neutralized by cobalt 3 plus. The coordination number 6, all the 6 positions are occupied by negative bidentate ligand oxalato. 1 oxalato 2 minus, 3 oxalato 6 minus. When you add these two, you will get minus 3. That 3 is here, this 3 is there. 3 get cancelled. So number of complexes we have written, all these are bimetallic complexes. In bimetallic complexes, both the cation and anions are complex cation and complex anion. Now we are going to name all these coordination compound. Naming of bimetallic complexes now start. Now we are going to write the name of, IUPAC name of all these bimetallic coordination complexes. First cationic complex, only one type of homoleptic ligand we have, amine. How many amine we have? 2 amine. Therefore, diamine, double M, diamine. So cationic complex, the central metal ion name end with SH, silver. There is no argentate, silver, oxidation state to 1. And the anionic complexes, Cn2, therefore cyanide, ambidentate ligand, the donor atom is carbon, that is indicated by kappa C. Au, negative complex, name end with 8, R8, coordination number 1. Diamine, silver 1, dicyanide, kappa C, R8 1. Come to the second complex, this is our ethane 1, 2 diamine, only 1. Therefore, that should be written inside the square bracket, inside the bracket, ethane 1, 2 diamine, silver cationic complex. There is no change in the name of the central metal ion, silver, oxidation state 1. Come to anionic complex, we have a bidentate ligand, that is oxalato, only one oxalato. Central metal ion Au, it is an anionic complex, therefore the actual name end with 8, R8, R8, oxidation state 1. Then come to the next 3 complexes, we are going to write the name. Aqua amine, 2 ligand, amine is first, starting with amine, then 1 aqua, amine, aqua, central metal ion gold, coordination number 1. Come to the anionic complex, we have bromido and chlorido according to alphabets. B is first, therefore bromido. bromido, chlorido, chlorido. Anionic complex central metal ion name, actual name of the symbol Ag, argentum, name end with ate, so argentate. Argentate. The oxidation state of silver equal to 1. Come to the other two complexes, that is aqua complex, 4 aqua, tetra, tetra, aqua, aqua, copper, tetra, aqua, copper. Then oxidation state equal to 2. It is a cationic complex, therefore the name is as such. But anionic complex, how many iodido you have? Tetra, tetra, iodido, iodido. Nickel anionic complex, name end with 8, so nickelate, nickelate, oxidation state 2, nickelate, oxidation state 2. Roman numeral we have to write. Come to this complex, here you have amine A, cyanido C. Amine is first, so triamine, triamine. Cn, cyanido, cyanido. Kappa C, kappa C, kappa C means donor atom is C, ambidentate ligand. Cationic complex, no change in the central metal ion, copper, copper. Oxidation state of central metal ion 2, Roman numeral. Come to the anionic complex, we have C, A first, C second. Starting with the amine, how many amine we have? Only one amine. How many cyanido? 3 cyanido, therefore amine. Tricyanido, it is an ambidentate ligand, therefore donor atom should be indicated, kappa C. Anionic complex, therefore central metal ion name end with 8, platinate, platinate. What is the oxidation state? Here 2. Now come to the other ligands we have, that is other complexes already we have written. What are they? That we are going to discuss. Bimetallic complexes, first cationic, but here we have ethylene diamine, IUPAC name ethane 1,2 diamine. How many? 2. So the number of ligand now indicated by pis, pis. Bi means 2. Because ethane 1,2 diamine, the name itself containing 2 di. Therefore its number is indicated by pis. IUPAC name of ethylene diamine is ethane 1,2 diamine, ethane 1,2 diamine. Central metal ion nickel, oxidation state 2-way, central metal ion nickel, oxidation state 2-way. Come to the anionic complexes, dioxalato, OX means oxalato, dioxalato. Central metal ion anionic complex, name end with 8, platinate, platinate. Oxidation state of central metal ion is 2. Then come to next complex, more number of ligands are present. According to alphabets, we have to order the ligand. Amine, chlorido, ethane 1,2 diamine. All are only one. Therefore, starting with the amine, first alphabet, amine. Chlorido, second, chlorido. Then ethane, ethane 1,2 diamine. Central metal ion platinum, cationic complex, there is no change, therefore platinum, oxidation state 2-way. Come to anionic complex, we have amine, chlorido, oxalato order A, C, O. So first amine, amine, Second C, chlorido. Third, oxalato. Central metal ion anionic complex name end with 8. Zingate. What is the oxidation state? 2. Come to the next complex, cobalt chromium complex. Only one type of ligand, homoleptic. 6 amine, hexa. NH3 amine, hexaamine. Cationic complex, central metal ion, cobalt. Oxidation state 3. Anionic complex, 6 cyanido, hexa, cyanido, ambidentate ligand. Donor atom should be indicated, kappa C. Then anionic complex name end with 8, Cr chromate. Oxidation state 3. Oxidation state 3. The next complex containing neutral and negative ligand. How many aqua you have? 5 aqua. A is first, C is second. Penta, aqua. Cn cyanido, kappa C. Cobalt central metal ion cationic complex. So name as such, cobalt. Oxidation state 3. Anionic complex, A is first, C is second. Starting with aqua. How many cyanido? 5 cyanido. So penta, cyanido, ambidentate ligand, kappa C, donor atom C. The anionic complex central metal ion name end with 8. Therefore, chromate. Oxidation state of central metal ion is 3. Chromate 3. Ion complexes. This is where ethane 1,2 diamine chlorido. How many Cl we have? 2 Cl. Therefore, dichlorido, pis, ethane 1,2 diamine. Ethane 1,2 diamine. Cationic complex, therefore there is no change in the Fe. Ion oxidation state 3. Then anionic complex aqua oxalato. How many aqua we have? 2 aqua. Therefore A is first, diaqua, dioxalato, cobalt anionic complex, therefore name end with 8, cobaltate. Oxidation state equal to 3. Come to other complexes, a number of ligands we have in these complexes. Amine A, cyanido, first letter C, nitrito. These two are ambidentate ligand, starting with A, alphabets A. Tetra, NH3, amine, tetraamine. C, cyanido, kappa C, and nitrito, kappa, donor atom N. Central metal ion, iron oxidation state equal to 3. Come to anionic complex, we have aqua and cyanido. A first, C second. How many aqua? 2 aqua. So diaqua. How many cyanido? tetracyanide. Donor atom kappa C. Anionic complex, actual name of Fe, ferrum, that name end with 8. So ferrate, oxidation state is 2, ferrate 2. Aqua and chlorido, A first, Cl second. How many aqua we have? 4 aqua. Therefore, tetra aqua. How many chlorido? Dichlorido. Cationic complex, therefore chromium. Cationic complex, chromium. Oxidation state 3. Come to anionic complex, this is chlorido aqua. How many aqua? 2 aqua. Diaqua. Tetra. Chlorido. Cobaltate. Anionic complex, central metal ion, name end with 8. Cobaltate. Oxidation state 3. Come to 2 more complexes. Cationic complexes. We have 6 aqua, hexa aqua, central metal ion chromium, hexa aqua, chromium, oxidation state 3. And anionic complex, amine cyanido, only one amine. So amine, CN cyanido, 5 cyanido, penta. Cyanido is ambidentate ligand. So kappa C, donor atom. Anionic complex, central metal ion, name end with 8. Chromate, oxidation state 3. Come to the last complex, ethane 1,2 diamine. Therefore, their number should be indicated by tris. What is the name of En? IUPAC name. Ethane 1,2 diamine. Ethane 1,2 diamine. Central metal ion. Cationic complex. Therefore, chromium, oxidation state 3. Anionic complex, oxalato. Central metal ion, cobalt. Anionic complex, therefore name end with 8. Cobaltate. What is oxidation state of cobaltate? 3. Because this is anionic complex. So, in this video we have discussed so far how to write the bimetallic complexes. Bimetallic complexes are the complexes in which both the complex cation, complex anions are present. A number of complexes we have discussed and a name also discussed. In the incoming video we will discuss the evaluate yourself problems. What are the complexes given in our syllabus that we are going to discuss. How to write, how to name. Thank you for watching this video. If you like this video, please subscribe my channel. Thank you very much.